This study leverages technology to support resilient urban forest design and planning by providing an application for assessing and comparing local-level urban street tree diversity and equity. Urban street trees are essential infrastructure. Yet, despite their importance, many cities struggle to design and manage street tree systems that are both resilient and equitable. A core challenge is biodiversity. Urban forests, dominated by a few species or age classes, are highly vulnerable to pests, disease, and climate stress. To reduce this risk, practitioners rely on diversity benchmarks such as the 10-20-30 rule, among others, and age distribution targets like the 40-30-20-10 rule for diameter classes. However, existing studies often focus on single cities, they lack standardized data, or fail to evaluate diversity and equity together across comparable spatial scales. This study addresses those gaps. We developed an open-source R-Shiny application, the Urban Forest Biodiversity Explorer. We standardized street tree data, calculated biodiversity and age diversity metrics, and mapped outcomes at citywide and neighborhood scales for 26 U.S. cities. The study asked three main questions. The results reveal substantial variation and widespread shortfalls. No city met LEF's 5-10-15 rule. Only 3 cities successfully met the 10-20-30 rule. Many cities shared similar dominant species, raising concerns about regional vulnerability to pests and climate stress. Age diversity showed a similar imbalance. 6 cities met Richter's age benchmark, but many cities exhibited skewed age distributions.
At the neighborhood scale, no city met all diversity targets. We also found clusters with low diversity and uneven age distribution, showing stronger local gaps. Cities such as Cambridge, Denver, and Washington performed better, with more neighborhoods meeting the softer biodiversity benchmarks. Our equity analysis showed strong links between social vulnerability and lower biodiversity outcomes. Census tracts with higher minority populations and more households without cars tended to have lower species diversity. Governance type also mattered. Tracts with public or mixed public and private programs generally showed higher biodiversity. Private programs, however, were somewhat associated with optimal age distributions. These patterns are not necessarily causal and may also reflect institutional or data differences. Overall, this study provides standardized metrics and an open-source tool to guide planting efforts, improve species selection, and prioritize investments in neighborhoods that fall short of resilience targets. Thank you for watching our presentation.